2018 was the fourth warmest year in recorded history, and the 20 warmest years in recorded history have all occurred in the last 22 years. Today, I will be discussing greenhouse gases and how they impact global temperatures. I will also look at the growing trend of electric vehicles and how they compared to the internal combustion engine vehicles, or ICVs, that most of us drive today. According to the EPA, 56% of greenhouse gas emissions in the US are produced by the transportation and electricity sectors. Battery-powered electric vehicles cause these two sectors to overlap. Through my research, I have come to the conclusion that purely battery-powered electric vehicles will not provide a significant reduction in greenhouse gas emissions compared to ICVs. To understand the issue, though, we really have to look at what are greenhouse gases and how do they actually impact temperature. According to the Environmental Protection Agency, the EPA, greenhouse gases are gases that trap heat in the atmosphere. The most common greenhouse gases in the US include carbon dioxide, methane, nitrous oxide, and fluorinated gases. Most of these greenhouse gases are produced from either burning fossil fuels during transportation or electricity production, or through industrial chemical processes. These greenhouse gases, they disrupt the Earth's natural cooling and heating cycle, which kind of follows a day-night cycle. During the day, the Earth absorbs heat via the sun's radiation, and during the night, the Earth cools and releases some of that heat into the atmosphere. Normally, this heat would dissipate back into space. However, greenhouse gases have the potential to trap that heat and lead to an increase in temperature. So to kind of give an example of that, I have this little diagram to show. So here you can see on the left a natural greenhouse gas effect. You have the sun with its solar radiation beating down onto the Earth during the day. Then at night, much of this heat will re-radiate out, and a lot of that will escape into space. Some of it will re-radiate and be re-emitted back towards the Earth. On the right, we have the human-enhanced greenhouse effect. So you also have the solar radiation coming in during the day, and at night, that heat is re-radiated back out. However, now you have a bunch more carbon dioxide and greenhouse gases in the environment, which then absorb that heat that's being re-radiated, and they re-emit that heat back down towards the Earth instead of letting it escape into space. And that rise in temperature can lead to a myriad of effects, mainly being more powerful weather cells, ice melt, which leads to rising sea levels, and that ice melt can also lead to a lot more fresh water in the oceans and a lot more CO2 being deposited in the oceans, which can lead to acidification. So concerns over global warming and greenhouse gas emissions have really led to a surge in research and development for alternative to internal combustion engine vehicles in the last few years. And Elon Musk, who is the president and CEO of Tesla, I'm sure you've all heard of Tesla, has been quoted as saying that he will not stop until every car on the road is a electric vehicle. But I don't really know if that's a goal that we should be aspiring to. One of the most popular papers that talk about the implications of producing lithium-ion batteries for battery-powered electric vehicles on a large scale was a life cycle assessment conducted by a team of scientists led by Dominic Notter back in 2010. The study found that the production of BEVs resulted in slightly more pollution than ICVs, but the bulk of the pollution still comes during the operational phase of the vehicle. So for an internal combustion engine vehicle, that would be burning fuel and burning gasoline. For battery-powered electric vehicles, it comes from the electricity that's used to charge the battery. The study concluded that unless all the electricity used to power BEVs is produced by hydroelectric power, the reduction in emissions compared to ICE Vs will really be marginal. So that raises the question, should we continue just driving our ICE Vs and not really worry about it? I would say no, and that currently our best option is through hybrid vehicles. So what exactly makes a hybrid? A hybrid usually consists of three things. There's a smaller, more efficient internal combustion engine. There's a thing known as regenerative braking. And third is a small lithium-ion battery. What regenerative braking is a development or technology that uses the energy from braking to spin a turbine, and that turbine in turn will charge that small battery that is on board your car. And then that battery will kick in during the highest fuel usage times of your drive, which is accelerating from a dead stop or when you're trying to accelerate uphill. So with those technologies in mind, I really think Elon Musk's quote should be changed to, "We will not stop until every car on the road is a hybrid." All of the studies that I've read really have come to the same conclusion, which is that cleaner energy sources are really needed before lithium-ion battery-powered electric vehicles are actually an improvement over our current internal combustion engine vehicles. And if we were to make that swap, we really would just be problem shifting, and now our main issue, instead of the pollution and CO2 that's emitted by our vehicles, becomes the pollution and CO2 that are emitted by our power plants that charge those vehicles. So if you want to do your part to help reduce greenhouse gas emissions in the near future, I would suggest considering for your next car purchase having that be a hybrid vehicle. Thank you, and have a good day.